I'm Nitin Dahad with the Times, and I'm talking now to John Kourentis, who's with ARM. John, hello.
Hello. Hi, Nitin.
John, what's your title? I missed it out.
So I lead our automotive go-to-market activities for the EMEA region.
Good. Now, we've just come to the end of your the Imec Automotive Chiplet Forum, which you've hosted. How's that gone?
It's fantastic. We had over 50 companies here yesterday and today looking at how we progress the market in terms of chiplets in the automotive space. So about 120 people from over 50 companies.
Okay, and what was your main sort of feeling as to the outcome of that? What were the key sort of takeaways for you?
Well, look, I think the key thing around accelerating the path of chiplets is bringing the ecosystem along, right? Pace of standardization is really, really important, and I think particularly in a market like automotive where development product cycles can be quite long, it gives us an opportunity to really make progress in terms of standardization and delivering the key building blocks and components that are needed for products to be delivered into automotive production timelines.
Okay, what are the key things that ARM is involved in facilitating here?
Yeah, so there's various different tracks to Imec's efforts around automotive chiplets. We're involved in both the Automotive Chiplet Forum, which is an open ecosystem of partners that come together every 6 months, and we had the pleasure of hosting it here. They also have the Automotive Chiplet Program, which is a smaller number of key partners that are working in a pre-competitive research environment where we're all making various different contributions in order to accelerate the path to chiplets in automotive. So as part of that, ARM's contributing our latest automotive IP that we released just last year as the building block for those research experiments to take place so that we can define some key chiplet types that we'd expect to see in automotive that can be built on the actual IP that you would expect to see in future generations of semiconductors. In addition, we're providing our guidance around chiplet system architecture that ARM has already published. The CSA program that we've launched, exactly that, Nitin, to provide guidance around how do you go about decomposing a monolithic SoC into various different chiplet archetypes that make sense for the end market that you're trying to address.
You know, I can just imagine a complete Lego robot, and then you'll just decompose all of that into little modules.
Yeah, and I think that's one of the challenges. That's absolutely the nirvana that we're searching for, right? That end goal is this open ecosystem of third-party chiplets that OEMs and tier ones can choose from and integrate together. Yeah, in reality, there are some steps that need to happen before. There are some steps that need to happen, and particularly, around standardization to enable interoperability of chiplets from different vendors. That's one of the key pieces, along with ensuring the quality and reliability that you need for automotive environments. Both temperature, vibration, all of those things are pretty harsh, in comparison to high-performance compute in a data center, for example. So there's a lot to consider for automotive.
And I think one of the things you were telling me earlier is if you just let the market forces work, you might end up with a lot of fragmentation.
Absolutely.
Because you've got such a, I don't know if it's called a binding effect, but because you've got this ecosystem, maybe you can help bring some of that together to be less fragmented.
Yeah, absolutely. That's one of the core competencies of ARM is landing a common architecture into the semiconductor ecosystem and the software ecosystem that can then build on that to deliver a foundational platform that the industry can rely on. And we see this transition to chiplets as a real opportunity where our chiplet system architecture guidance can be used by the entire industry.
Okay.
Those building ARM chiplets and those connecting to chiplet environments based on ARM to enable that interoperability and fundamentally to enable software to land on those environments and work effectively.
Now, you may not like this question, but obviously, if you're building a standard, then it can be ARM or non-ARM chiplets.
Yeah.
Is that right?
Yeah. So if you look at CSA, what it looks to define is a common set of guidelines where ARM chiplets can work together and present a uniform interface for software to work. So we have chiplet system architecture and we have a base system architecture. So a set of CSA compliant chiplets should be able to work together to present a BSA compliant interface for software to run as if it was running on a monolithic SoC. Okay, so it sees that collection of ARM-based CSA compliant chiplets as one interface from a software perspective, with then the ability to plug in non-CSA compliant chiplets that may be accelerators that have some secret source for an OEM, and then plug that into the system for that all to work cohesively.
And can we expect CSS components coming up this year?
Yeah, so last year we launched our
It's a chiplet subsystem.
Yeah. So last year we launched our latest automotive IP.
Subsystem.
We launched our latest automotive IP. We will be, we've already launched compute subsystems for the infrastructure space and mobile, and later this year we'll be launching our automotive CSS.
Okay. John, thank you very much.
Thank you, Nitin. Pleasure speaking to you. Thanks.